Section 4.6. In part, we're going to be looking at applications of irrational equations and inequalities. And in Part A, we'll look at a couple of different kinds of word problems. The first one has to do with revenue and cost and profit for a company. We have a company producing and selling phones. Manufacturing costs are $80 per phone, with an additional daily overhead cost of $6,000. I'd like to start by looking at the daily cost of producing X phones in a day. That's what we're going to call C of X. Now we know our daily overhead is $6,000, so it's going to cost us $6,000 no matter what, even if we don't produce a single phone. But then it also costs us $80 for each phone that we produce. So if I take 80 times the number of phones I make and add the $6,000 overhead cost, that should give me the total cost for the day. Now I'm looking for the average manufacturing cost per phone. To figure out the average, we always take the total and divide by how many things we had. So in this case, the average cost would be the total cost divided by the number of phones that we made. Now my total cost we just wrote down, 80x plus 6,000. And the number of phones, we're making X phones per day. So there's my equation for average cost. The question we're being asked now, how many phones should be produced in order for the average cost to be less than $100 per phone? So I want average cost to be less than 100. I'll take my average cost function here and say, when is that less than 100? We're going to go ahead and solve this one by hand, and then I think the next one we'll use some technology, so we'll get an example of each here. If we're going to solve this inequality by hand, I'm going to start by saying the only bad value of X would be 0. That would be my domain. And then I'll look at the related equation. Changing that less than to an equals. All right, I would like to clear the fraction. So I'm going to multiply both sides by the only denominator, which is X. Divides out on this side, so I have 80x plus 6,000 equals 100x. And let's see, that'll give me 6,000 equals 20x. And it looks like x is going to be 300. If I go ahead and put that on a number line, my 0, which was the excluded value from the domain, and then the 300 that I got here from solving the related equation, I should be able to figure out when my original inequality is true. So I'm going to go ahead and put my algebraic fraction here into my calculator. And let's see, in the table, I'll test a couple of values. I'm going to go ahead and put in like a -5 or something like that over here. And I get -1120. and I want that to be less than 100, which it certainly is. Something between 0 and 300, maybe I'll pick 100. Gives me 140. Again, I wanted that to be less than 100. And that's not. That one's false. And then finally, maybe pick 400 over here. That gives me 95. Again, I want that to be less than 100, and it is. That's true. So technically speaking, my solution to my inequality would go from negative infinity to 0, and then from 300 to infinity. Realistically, though, x is the number of phones, and I cannot make a negative number of phones. So even though that popped out as part of my solution, it's not realistic. And it looks like I need to make more than 300 phones. To get the average cost below $100 a piece. All right, our second example of modeling with word problems here is an example of a travel problem. A student plans to drive home from college in Madison, Wisconsin, to Fergus Falls, Minnesota. This will require driving 204 miles in Wisconsin, speed limit 65, and 240 miles in Minnesota, where the speed limit is 70. Find a function t of a that gives the driving time if the student drives a miles per hour above the speed limit. First of all, I need to remind you of something that you probably learned back in an algebra class somewhere along the way. Specifically, time is distance divided by speed. Right? A really simple example, if you want to go 60 miles and you're traveling 60 miles an hour, 60 divided by 60 gives you the 1 hour that it'll take you, right? So distance divided by speed gives us time. In this case, we're going to have to actually split that up into two parts. One part for the part of the trip that's in Wisconsin, and the other part that's in Minnesota. So I'm going to actually do a little bit more out here. I'm going to say this is the distance in Wisconsin divided by the speed in Wisconsin added to the distance in Minnesota divided by the speed in Minnesota. That'll be my total time function. Now the distance in Wisconsin was 204 miles. And the speed limit's 65, but the student's going a miles an hour above that speed limit. So we're going to go a plus 65 here. Plus in Minnesota, we're going 240 miles. Speed limit 70, but again, still going a miles an hour over that. So a plus 70. And there's my equation for how long it will take if the student drives a miles an hour above the speed limit. Part B asks us to find t of 0. And although that's not a difficult thing to do by hand, I'm actually going to solve Part C using technology this time. So let's go ahead and put this in the calculator since we're going to want to do that anyway. Again, if you're working with Desmos, that's an excellent choice when we're working with these. Calculator is just easier for me to show on my screen right now. So I'm going to put in my equation here. again, I'm going to draw a graph of this. Now keep in mind our x or a value is just how much we're exceeding the speed limit by. So when I think about my window, I guess I could go less than the speed limit, so maybe -10. And let's say we don't want to go crazy here. Maybe we would never go more than 20 miles above the speed limit, hopefully not that much, right? And the y value is the time it's going to take to make this drive. I have to have a positive time, so I'll start at 0. I certainly don't think it'll take more than 10 hours, so I'm comfortable with that. Here we go. Let's see. If I want to plug 0 in to my function, I could do that easily just by saying, what's the value when x is 0? And it looks like we're at about 6.567 hours. So 0 is how much we're speeding, meaning basically if we go exactly the speed limit, the trip takes a little more than 6.5 hours. All right, the second part of this says find A so that T of A equals 6. So I got to put the 6 in on the left-hand side here. 6 equals all of this. Okay. Now, that equation is solvable by hand, but there's some pretty ugly common denominators with some pretty large numbers. So although we could do it, this is a great time to go, hey, let's use the technology instead. I already have the right-hand side graphed on the calculator, so let's just graph the left-hand side. This is already in as the y1. I'm going to put this in as the y2. And the solution is where they intersect, right there. And I get x, or in our case A, is about 6.38. So what does that mean? Well, the time was 6. So in order to make the trip in 6 hours, we would have to exceed the speed limit by 6.38 miles per hour at all times. All right, that's the end of Part A, and we'll do Part B in the next video.